Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Dogba Jr., your math tutor and an instructor of mathematics at the University of Liberia. In my today's lesson, I will be looking at differential equations and particularly type 2 of variable separable method. So in type 1, we look at problems where we can easily separate the variables given a differential equation, and then we can integrate both sides after the variables have been separated. But there are certain problems that you cannot easily separate the variables. So you will have to manipulate the problem first using some derivative and some substitution. Then before the variable can be reduced, before the differential equation can be reduced to a variable separable problem, then you can apply variable separable method. So let's solve additional problem on a reducible to variable separable. So in this case, we look at the inner portion, this portion, because this inner portion has two distinct variables, x and y. So we know that since x is the independent variable, if we differentiate x, it goes to a constant. So it means x will be eliminated from here, and then we'll only be left with y. So we can substitute. We say let u equals to x minus y, such that du by dx is just equals to 1 minus dy by dx. So the next target is to be able to solve for dy by dx. So to solve for dy by dx, we have the u all over dx, that's a minus 1 is equals to minus dy by dx. So we can just send this, one across, this dy by dx across to be positive dy by dx, and then equal to 1 minus du by dx. So this is our dy by dx, which is this portion now. So we need to replace what is here. So what is here should be our u raised to the second power. Then dy by dx now is 1 minus du by dx, or equals to a squared. So if we multiply now, we just have u squared minus u squared du all over dx equals to a squared. So we can just multiply this whole thing by dx. We'll have u squared dx minus u squared du equals to a squared dx. So we can now put dx on one side of the equation. So we have minus u squared du equals a squared dx minus u squared dx. So what happens if we even multiply all sides, right? Multiply all sides by negative. We have u squared du is just equal to, so this one will be positive now, so I can write this one first. So dx and dx, we can just factor it out, minus a squared dx. So have the variables been separated? No. So we divide this side by u squared minus a squared, and then this side u squared minus a squared. So this and this cancel. So we have u squared du all over u squared minus a squared equals to dx. So the variable have been separated. Now we can integrate both sides of the equation. So we can now integrate both sides now to be able to solve that problem. So we know that when the power of the numerator is equal to the power of the denominator, we can apply long division. What if we don't want to apply long division? Long division, then we decompose the problem. What if we don't want to go that route? We can rewrite the numerator. That is, we can have u squared. Now, this is a squared, right? This negative a squared. So we can add a squared and subtract a squared from the problem. It's still the same. So we can say u squared minus a squared, then we say plus a squared. So it's still u squared. It means nothing. Divided by u squared minus a squared. Du equals the integral of x is just dx is just x. So this now we can open it up. U squared minus a squared all over u squared minus a squared du plus the integral of a squared all over u squared minus a squared du equals to x. So this will just be equal to the integral of 1 du plus, now a squared can come outside. We have 1 all over u squared minus a squared du all equals to x. So we can bring in the property for that expression. We know that that is like 2a all over, let's say 1 over 2a ln of u minus a divided by u plus a. So we can just bring in the ln, because that's a property. We just bring in the property for it. So the property for this one, in fact, let's write it right here. Let's write it right here. Okay. So the integral of this one is just u plus a squared now. Now this one is just 1 all over 2a. So whatever expression that is here, so it's 2a, right? And then times the ln of a minus, let's say u minus a, so it's u minus a divided by u plus a. Then we have equals to x plus some arbitrary constant c. But originally we did not have u in the problem. Originally we had y. The original problem was y. So we need to substitute, we need to substitute the original variable of the problem. So this is u. Now we know that we said u should be equal to x plus y. So let's keep that. U should be equal to x plus y, or x minus y, because this is minus. So now we have u, which is now x plus y, plus a squared. Now this a will cancel 1 from here. So you just have something like a over 2, the ln of, now this u is x minus y, minus e all over x minus y plus e equals x plus some arbitrary constant c. But what do we know? This x, get a blue chalk, a blue marker. This x and this x can go out, because even if it goes across, it still becomes the same, right? So that and that can also go out. So we can have y now to be equal to, we can send that entire ln on the other side of the equal sign, or if we like, we don't do that, but we can just send that entire expression on that side of the equal sign. Sorry, we had this u to be equals to x minus y. This u, x minus y. Okay, so we can have y. Let's make it in a way that you understand it. So it's a over 2 ln of x minus y minus a divided by x minus y plus a, all equals to c. Now, if we multiply this entire thing by negative, we will have positive y minus a over 2, the ln of x minus y minus a all over x minus y plus a, all equals to c. So if we send this one across, we send this entire across, we will have y now to be equals to positive a over 2 ln of x minus y minus a all over x minus y plus a. plus some arbitrary constant c. So if you like, you can stop here, or we can rewrite this c as ln of c, and then this a over 2, we can raise it to the power, so it's y ln of x minus y minus a, or over x minus y plus a, all raised to the power a over 2, and then plus ln of c. So ln of a plus ln of b, ln of a plus ln of b is equal to ln of a times b. So we can combine these two. So y would just be equal to the ln of, so it's like c times this one. So it's c times x minus y minus a, x minus y plus a, all raised to the power a over 2. And then this is our general solution using reducible toe variable separable method. So thanks ever so much for watching. Please do not forget to subscribe, hit the notification button. Thank you.